Okay. So, for example, in the case of parenthetic notation, you can apply that we did in during the lectures, vertically one object above the other. So you can do that. But for simplicity, you can also write that horizontally. So you can say that this here is A or B or C. And that means 0 or 1 repetition of objects A or B or C. Is this okay with you? You can do it that way because we said that you can write it also horizontally. So if you write it horizontally, it is easier for typing. And then here, if you put here 3 dots, then that means that this can repeat any number of times. But since it can be 0 or 1, that means you have 0 or more repetitions on one of these objects, A or B or C. So you can write it in that way. And then if you have curly braces, you have A or B or C, but that means you select one of these objects. Ideally, you put that vertically, one above the other, A above B above C. But if you put this vertical line for or, then you simply select one of these objects, A or B or C. And then when you put here 3 dots, that means that this repeats one or more times. And this is rather simple. So if you have this notation, then you can say, for example, 0 with 3 dots. That means it is either empty or 0 or 0, 0 or 0, 0 repeats multiple times. Okay. And then if you have a single digit, like here, this is digit 0 or 9 or 7 or any of them. And then after that, you have from 0 through 9 with 3 dots. That means that this can repeat any number of times. So it is either 1 or 2 or 3 of these digits, and this is unsigned integer. Okay? And then if you do that, then you can solve all problems on a single slide. Very simple. Natural number, unsigned integer, etc. Now, it is giving you a little bit of insight into parenthetic notation, how you can do that. It is simple. It is fitting on a single page. Any other question? Okay. Is this the answer to your question, sir, or you need something more?
No, I think that makes sense. But just quick clarification for that last one, which is 1 or more repetitions, that's supposed to have curly braces, right?
Yes. Since if you put this in curly braces, like here, that means you select one of objects that are inside. Now, ideally, I would put big curly braces and we'll put 0, 1, 2, 3, one above the other. And this looks very nice and it is intuitive and take a very not long line. It is very narrow. However, if you put 3 dots after that, that means previous object repeats any number of times. Now, if the previous object is curly brace that is selecting one of them, then that means you can have any number of digits. And any number of digits is a string that consists of digits, and therefore you have that this is now an unsigned integer. So 1, 3, 5, 7, 2, 2, 3. Okay, so integer that is rather longer, that is unsigned integer. Okay, so you can do it this way, and it is easier for typing because, like I said, if you have to here is unsigned integer 0, 1 through 9 with 3 dots, and that is one of your objects. For these others, you do the same. Very simple. Fits on a single slide here. Have you survived with the second question. Regarding these questions, number one, okay, if you have syntax diagrams, you can do them in this ugly way, or at least I can do them in this ugly way, because it is easier. You just take any uh, text editor and you can put this. It is understandable. If I put here 0 or 2 or 4 or 6 or 8, that means it is one of them. And here is 1 through 9, it is one of them. Syntax diagrams, BNF, and everything else is made for human consumption. And if it is understandable for whoever reads that, then it is okay. You have to describe the syntax of an object and to do that in a way that humans, that means graders, can understand. And as long as you explain your notation, that is more or less okay. In the case of BNF, you have plenty of options. You can do it in one way or in the other way, or here I have, I don't know how many, you can say number has prefix and suffix, and prefix is any unsigned integer or empty, and suffix is 0, 5 or 3, 5, 9 or 2, 4. So you can do it in a short way or long way or different way or whatever. But here the rules are rather clear. So this is a solution more than you need in usual BNF notation. And in the case of syntax diagrams, you can do them either in nice way using Microsoft Word or using just Notepad or Notepad++ like this. This is still understandable, you know. This is integer. You have plus or minus or empty, and you have here one of digits that can repeat any number of times. So fine, this is integer. It is readable, it is not beautiful, but it is not ugly, and it is understandable. So something like that. For parenthetic notation, I put that horizontally to make it short and simple. And for this second problem, for assignment, well, that is something that you can do the same way it is done in the reader for eBNF. You have there one explanation of what is expression, okay? And the way how I did that in solutions, I simply took basic components that are used in expressions that I need up front so that I have them when I need them. And then digit is 0 or 9, letter is this, sign is this, empty, unsigned integer, integer, real, number, addition, operator, multiplication, operator, and identifier. You need that always, so you put them up front that you have them. Now, when you have them, you say, assignment is variable equals a real expression. And then you define what is variable, blah, 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 variable. And then input expression is term plus term plus term or whatever else. Because integer expression is what you have inside the index as the index that you have. And then after that, real expression that has this real term, because here this real expression can have numbers that are written as values that have a point. So you have to define this number, okay? And numbers are defined here up front, real, that has a sign uint or uint with dot or sign with uint and stuff like that. Is this more or less what you did?
I think so. I don't know.
Okay.
I think so.
Okay, that's good. That's good. I've seen a few submissions yesterday that some people submitted, and all of them are absolutely perfect. There are going to be plenty of 100 points. So for those that submitted, I'm very happy to see what is over there. So we'll say, ha, it is, it is working fine. And for rest of you, you can till midnight to submit today. Okay, so please pay attention that you cannot submit at some other time, because this is computer program that is checking whether the time is correct. So don't do that at 11:59 because that is when the the homework will no longer be accepted. Okay, so submit whatever you have on time. That is important. So if there are no other questions, I should go to continue with our procedural programming study. We studied procedural programming last time, and let us continue in this direction. Do you see this slide entitled Basics of Procedural Programming? Is this working properly on your screen?
Yeah, we can see it.
Okay, if it works, let's continue from here. So we said that in classification of languages, we have those languages that are developed for procedural programming, like Fortran or C or any other language that is similar to that. And you have logic programming, which is usually exemplified using Prolog, and then functional programming, Lisp, Scheme, and many other languages, and object-oriented programming that includes also multi-paradigm programming like Ruby that covers procedural, functional, and object-oriented in the same language. Java is object-oriented, C++ is also object-oriented, C#, Python, etc. Multi-paradigm languages support more than one paradigm, and that is good. For example, in the case of C or Fortran, only procedural programming. When we speak about C and Fortran, we speak about classical versions. Fortran evolved in many dialects, so up to 95, this was the classical Fortran. All languages have procedural components. That means addition, subtraction, etc. You can do in all languages. The basis of all programming is procedural programming. Object-oriented is just a layer that comes on top of a basic procedural programming. So that is what comes on top. The basic goal of procedural programming is to achieve high performance of software products. So to make products that are both short and fast. So not gazillion lines of code, no brute force, but short, fast, elegant, and efficient. So that's the idea of procedural programming. If you have short program, uses minimum of memory. If it is fast, it uses minimum of processor time. And it should be accurate. All significant decimal digits should be accurate. Therefore, no things on the screen that is numerically or completely wrong, but it should be correct, fast, and short. So this is the ideal of programming in any language. And procedural programming is emphasizing this criteria. So that is what is important. There is difference between procedural and non-procedural programming. This is difference between what versus how. In non-procedural programming, we are not specifying detailed procedure how the processor and memory should move data in order to solve the problem. For example, in assembly language, you see explicitly that you move data from register to memory, from one memory location to another memory location, and you see loops and everything else that you adjust the way processor is supporting that. So you have that procedural programming is close to hardware, and non-procedural programming is specifying what you want to do, not how to do it. So non-procedural programming is close to problem specification as opposed to specification of hardware activity. So in non-procedural programming, you have less programming effort. So we work less, but you have lower performance that you get, because if you don't have detailed specification what has to be done, then somebody else has to do that automatically, and this generates lower performance than in the case where you have procedural programming. So in procedural programming, we have to specify basic data types, basic control structures, expression evaluation rules, what can be done for program performance, what are tricks that we used in order to improve program performance, and we care for accuracy of results. So this is the set of criteria for procedural programs. And then one thing that we can do is to specify generally what languages have to support, what kind of data types and what kind of control structures. And we can call that a general pseudo language, which is very useful when we do anything that is related to program development. So practically, this is what we suggest that we use when we develop programs. So you can think of program as a mathematical object or program as an engineering product. Program as a mathematical object, that's how programming is interpreted by mathematicians. Program as an engineering product, that's what we do in software engineering when we develop software for users. So as a mathematical object, program is algorithmic solution, must be correct, and sometimes there is proof, formal proof for correctness. I don't know, did you do such formal proofs in some of previous classes, but these are rather long proofs. Then for a program that has 6 lines of code, the proof is 60 lines of code that it works, 50 lines of proof that it works properly. So it is not very practical to do that. And must generate solution after finite number of steps. Of course, mathematicians don't care what is the number of steps, because if it is correct, they don't care is it something that will run for 1 minute or will run for 1 second. For them is the same. For us, it is certainly not the same. As engineering product, you have that software is developed in industrial environment, and that means collaboration, competition, outsourcing, etc. So what are criteria that we have to satisfy? Well, program must be built according to specifications. So you first make specification, and then you have to implement that. It must be correct as mathematical object. It must generate correct results. That is, of course, what must be satisfied. But it has plenty of other things that mathematical objects don't satisfy. So it must be robust, must be tested, must satisfy quality assurance standards, must be produced on time and within budget that you have, must be properly documented. If you write software for military, they say, okay, you develop software, but you have to give us installation manual, usage manual, and user manual and maintenance manual, because we want to maintain your programs. So you have to give us something that tells us what are internals and data structures that you use and stuff like that. It must satisfy usability standard and have nice user interface so that you can comfortably communicate with your program. It must satisfy performance standards, must be as fast as possible. Then it must be designed to be robust, maintainable, and if possible, reusable, so that when you make one such product, that you can reuse it when you develop similar products, so that you can make more money with less work. So these are engineering conditions that are present in procedural programming and in any other form of programming. Now, it is also important to make the difference between large and small programs. Okay, so inside a large program, there are always small functions. So if you want to have a good large program, you have to be able to satisfy the same criteria for small programs as for large program. It is not that small program can be developed without paying any attention to performance or something like that, because it is always used inside bigger programs, and big programs are, of course, built on many functions, so each function has to be good. So programming languages are, of course, tools for making software products, and making that is an engineering activity. So programming languages can be used for means of communication between human and computer, but it can be also communication between humans, between software designer and software maintenance engineer, the guy who has to maintain that. So whenever you write software, think about those guys who are going to make living by modifying your software. So think of them and put inside good documentation, document your code, and also write manuals that are necessary for that. And if you have to maintain your software, you are also going, after 2 years, completely forget what you have written, and then you will need documentation of your program, same as everybody else. So that is important. Okay, so the main rule for programming languages are that you can belong to many of them. Programming languages are not religions, so that you belong to one and not to the others. You can belong to many religions at the same time when we speak about programming languages. We do have very frequently young folks who belong to their native language, and they say, I like Python and I live in Python, or the other lives in IDE and inside is Java, etc. This is, of course, necessary for everybody who starts programming and has some native language, but try to have multiple languages that you use and multiple paradigms. That is extremely important for long life in the software area. And main rule, all programming languages are good, and they deserve respect for their features and their contribution to the development of art of programming. So no programming language was developed without reason and without some good properties. Okay, so each language has some unique and good properties. Therefore, each language deserves respect from our standpoint. And then simplistic classification is low-level languages, where assembly language is available, and high-level languages, that are languages above the level of assembly language. So these are simple classification, low-level and high-level languages. One high-level language instruction, for example, if you write in C++ and then compile that, and then look at code that is produced by compiler, you will see that on the average, one high-level instruction translates into 5, on the average, 5 assembly language instructions. Well, this has consequences. And consequences are that if you develop software in assembly language, this is going to have 5 times more lines of code, 5 times more documentation. You have in assembly write 1 comment per line. You write assembly language a line, put semicolon, and then say what this line is doing. So it is more documentation. It is less readable and more difficult for testing. And you have 5 times more programming effort and development cost. And you have, of course, dramatically better performance than if it is developed by high-level language. Because, of course, if you compare what humans write in assembly language and what compilers produce, you will see that human code is dramatically better. So compilers cannot produce quality that humans can do. and interpreters of high-level languages or virtual machine are even worse than that. But we don't have money to pay people to write these millions of lines of code in assembly language. Therefore, high-level languages are very good things to save money, not to make performance that is comparable with human-generated performance. So the idea is simply that only very critical code, for example, kernel of an operating system, is always having 20, 30,000 lines of assembly language code. And this must be done in assembly language, or a kernel of a database system, or device drivers that are used all time for various critical devices. This is also written in assembly language. But generally, commands of an operating system are written in C. Ruby is all written in C. So all professional software is usually written in C because it is very good quality, and it has still some comfortable things that are properties of high-level languages. So all high-level languages are designed for specific application areas: engineering, business, education, fast learning, system software, list processing, artificial intelligence, general purpose, for example, C++, Ruby for object-oriented programming, and web applications, because you have Ruby on Rails, which is framework for development of huge web applications. You have that all Twitter is written in Ruby. SQL for database application, Java for internet application and general purpose object programming, etc. COBOL for business, Fortran for engineering applications, Pascal for education, and BASIC for fast learning. Design the language that somebody can learn in 2 days. Okay, well, this is a huge challenge. So don't ever say not respect BASIC. BASIC was designed that people can learn how to write programs in 2 days. So this is a very tricky problem to solve. So when we have low-level languages and high-level languages, level means how far you are above the level of hardware. That is the meaning of high level. So primarily processor, of course, processor and memory. So low level is not automatically bad, and high level is not automatically good. This is just the term how far you are above the level of hardware. If you have very high level and lot of abstraction, like in Prolog, for example, that doesn't mean that this is going to generate fast code. You are going to be much slower than C program and much slower than assembly language program. But it is going to be very comfortable, and you're going to solve problems with 2 lines of code. Beautiful. Okay, you save your time, and you pay that with lower performance of product that is made. Now, same is with abstraction. If you have a higher the level of abstraction, it is more comfortable programming for humans. So humans, of course, are good in abstract thinking. So more abstraction, easier life. Okay. So if you have more abstraction, you have less performance usually. So you have to pay for these advantages that you have. High portability and abstraction, ignoring hardware performance. This is the characteristic of high-level languages. Big versus small language. Well, if you have a big language, you can always see that big languages have books, textbook that has more than 1,000 pages, and you can go from here to eternity and back. Small languages have booklets that have 200 pages. For example, take the book on C or Pascal, and you will see that these are tiny books that have 180 pages, and the whole language is inside. And you can have the sweet feeling that you know everything that exists in that language. And with big languages, there are gazillion of options that can be implemented. And of course, this is much more difficult for software engineers. Expressive power is something that is related to the programming effort. If you have high expressive power of language, then you have low programming effort. There are gazillion of different examples of that. Let me say the simplest of them. In all problems, or very frequently in programming, you need to have sets, work with sets, collections of objects. So if you have sets, then obviously you would like to have that your language supports set data type. So if the language does not support set data type, you have to do that manually. So it reduces your comfort and it makes higher programming effort, and higher programming effort is less comfortable for humans, and therefore it is better to have low software development effort, and this is when you have high expressive power. High expressive power means that whatever you want to express algorithmically, you have functions and support for that, and therefore it is easy to develop software. You don't have to do plenty of work. So let us say a few words about language-independent algorithmic thinking and procedural programming. So let us define one general pseudo-language as a complete collection of basic data types and complete collection of basic control structures, regardless are they supported or not supported inside your specific language. So this is helpful for your mental processor to develop software in your mind and then translate that into specific language that you use in a specific environment. So goals are to have language independent programming. That means to have general algorithmic thinking, not thinking inside the frame of a language. So you take a language, it is like a frame. You are inside frame and you have nothing that is not supported with that language. So it is important to go outside of that frame and to think globally and act locally inside one language. But when you think, you cannot think inside the language, you think outside. And then, of course, you translate that to specific language that you use for development of your software. So let us say a few words about some general ideas. And one of them is the idea of ordinal data type. Ordinal data type was introduced in Pascal, actually. And ordinal data type is each data type that internally translate onto ordinal numbers 0, 1, 2. So these are unsigned integers, 0, 1, 2, 3, 4, etc. So all data types that translate to that are ordinal data type. There is only one exception. This is that integers are not mapped to 0, 1, 2 because they map onto themselves. But all other things are frequently mapping on ordinal set of numbers. In particular, if you have, for example, things like Sunday, Monday, Tuesday, Wednesday, or you have variable that are January, February, March. So these are enumerated data types. So you say enumerated data type, I have this object, this object, this object, and this object, and they are always ordered. Ordinal data type is mapped to 0, 1, 2, 3. So Sunday is 0 internally, Monday is 1, Tuesday is 2. If you have logical data type in a language so that you have false and true, then false always maps to 0, true maps to 1. And since it is done that way, you have always the possibility to sort them. You know that Tuesday is greater than Monday. Wednesday comes after Tuesday. Saturday comes after Friday. So you have that ordinal data type is practically a sequence of sorted objects. So you can do sort by doing that. Of course, the simplest possible example is the character data type. Character data type has characters that are sorted according to ASCII table. So this is obviously mapped to integers, and all characters are sorted, and you have 65 for A, 66 for B, etc. Now, in the case of ordinal data type, you have three functions that are necessary for supporting such data type. The first is ordinal value, ordinal of X. So if you put here that X is character A, then ordinal value will be 65. It is going to return the value of your uh, uh, ASCII equivalent, okay, numerical value of that character. This character A is just for human consumption. It is not for computer. Computer doesn't have character A at all. It has ASCII code 65. So, and it is this 65 is binary coded. So there is no ABC for computer or string. It is just the string of ASCII characters and nothing else. Predecessor. Predecessor is function that gives you object that comes before specific object. So if you say, give me predecessor of B, it is going to give you A, or it is simply going to take the ordinal value of B and subtract 1, and then will give you the previous object. You are not going to have predecessor of first object, of course. And then you have successor. Successor returns the successor of X. For example, successor of A will be B. So if you have these functions, ordinal, predecessor, and successor, then you can have predecessor and successor loops that are available in Pascal. So what you have is the loop that is going for I is, for example, Z, down to A, do, and then you have the loop body, begin, end, whatever is inside. So you go through the sequence of ordinal value in opposite direction. When you say down to, you go from the last towards the first. So you go from 6, 5, 4 in this direction. If you have a loop that says for I equals character A to character Z, do this sequence, then you go in the sequence of increasing ordinal values. So you go from A to Z, and you see that here you have this keyword to, and here you have down to, okay, down to, because you go in opposite direction. Now, these are two important mechanisms, predecessor loop and successor loop. In the case of predecessor loop, the update that is not visible here, if you have down to, is based on index equals predecessor of index. And if you go here to successors, you have index is successor of index. So you can write a program that says for I equals January to December, do, and then you process something for each month. Or you can say from in working days, from let us say day equals Monday to Friday, do something. Okay, so for those components that are in this sequence of ordinal data type. So many data types are translated to ordinal. So if we want to see the classification of data types that are used in various languages, of course, when I say about ordinal and predecessor and successor function, you have that explicitly in Pascal, and it is very comfortable to have that, okay, and to have successor and predecessor loop. But if you go to C, you don't have it. And then you have something else that is equivalent or similar. But this is the concept. And when you have the question, what are data types that are available in programming languages? Then you have this long list here. And you can say that basic data types can be always decomposed into two big groups, static and dynamic data type. So what are static data types? Well, It can be scalar or can be structured. Okay, if you have set, it is structured data type. It has components that are somehow packed in one set. And you have various such structured data types. If you have scalar data types, well, scalar data types can be ordinal or real and complex. Real numbers cannot be mapped on ordinal number 0, 1, 2. They cannot be mapped to unsigned integers. They have mantissa and exponent, and this is a different world. Complex numbers also cannot be mapped, but everything else can. So you have that ordinal data types are logical, cardinal unsigned integer, integer from minimum integer to maximum integer, character is ordinal data type, ABC, characters used for digits 0, 1, 2, 3, 48, 49, etc. Enumerated data type, January, February, December, and subrange data type that is available in Pascal and tragically missing in C++ and similar languages. When you say Monday to Friday, so working days. So these two dots that tell you that you go in an ordinal data type from first to the last component. This is something that you need every day. And if your language supports that, that's a good language. If it is not supporting, then you have to think about that yourself. And it is not a pleasure. Or you say from 0 to 255. So this is something that can fit in a single byte. Okay, so all of them are ordinal data type, and all of them are implemented inside by mapping that data type to the set of ordinal numbers, unsigned integers, 0, 1, 2, 3, 5, etc. If you have character, you know that null is mapped to 0, and tilde is mapped to 127, and whatever we said else, lowercase a is 97 and lowercase b 98. So all of them map in the way that we said last time when we discussed that. Scalar data types can be real or complex, and you can say at 1234, and this is going to be translated into mantissa and exponent, and obviously this cannot be mapped on cardinal numbers, so 0, 1, 2. So these are scalar data type, and they are static. They are static. They are not going to change during the execution of your language. And you have also structured data types. For example, bit string. Do you have it or not in your language? Most likely not. But in your mental computer, you can have a bit string. Why not? With length that is constant. C string is a string that has a constant length. So it has ASCII character A, B, C, and then null at the end as a terminator. Okay. So this is array of characters or array. This is structured data type, array of 100. You have, or matrix that has 200 times 10. So these are structured data types. They have structured many components that you can select using some mechanism. Then you have set data type. For example, set of vowels, A, E, I, O, and U. And you define this as a set of vowel and then ask whether a character is a vowel. Well, it is a vowel, it is member of this set. So in Pascal, say, if character in this set, then do one thing. If it is not, do another thing. If you have to write some natural language processing program, you need to know, is it vowel or not? Because you have to decompose text into lines and several things. It is very good if you have sets, excellent. If you don't have it, this is miserable experience, you have to do it yourself. Then you have records. Record is very important. You can have point that consists of X and Y. But if you take, for example, your driver license, you are going to see that this is a record because it has a number of your driver license, expiration date, it has your address, which is another record. It has your first name and family name. It has plenty of other information inside. So this is the basic thing that you have in many programming languages. So I am asking you, how are you going to make a record in language X? If this language X is COBOL, you are going to have fantastic luxury in doing that. It's going to be easy. You are going to structure that. It is going to be structure inside structure, beautiful. If you take Fortran, then it is going to be much more difficult because this is not supported. Or you take C or C++, and you are not going to have that your, for example, file consists of records because they have only just a single stream of bytes and nothing else as a concept. So this is going to be more difficult. So various languages offer various degrees of comfort in writing programs. So we want to say these are general data types and how languages support them. Some support better, some less good. For example, after static data types, you have dynamic data types. What are dynamic data types? Well, these are data types that can have either variable size or variable structure. Okay. Now, variable size means you have, for example, dynamic array. So you say, I have the new integer array that has n components. And whenever you say, make for me a new array that has n components, somebody will come and make array with that component. So you can have a loop that in each iteration creates the new array with different size. Okay, so this is variable size, very nice thing. In Fortran, you cannot do that. You have static data type. It is static. You say, here is an array. It has 100 components, and that's it, neither more nor less. You cannot expand it and retract it. Of course, if you want to expand and have these things, you are going to pay for that with processor seconds, but it is going to make your life a little bit easier. So variable size is bit string, character string, set has variable size. You can always say, I have set 1, 2, 3, and now append to that, make union of two sets and merge them together, and then set is increasing. So it can have any length as set. Array can be dynamic. Of course, most languages are not going to give you stack or queue. For example, queue is a data structure where you have input and output. And you have plenty of queues. You have that programs are queued for printing, or queue is part of the operating system of gazillion programs need queues. So it would be nice to have data type queue that you said, I'm going to use A, B, and C, and they are going to be queues, 3 queues. But you don't have that. So some languages will give you that. GPSS that is working with queues, of course, will give you a queue because it is designed for that. But if you go to Java, no queue. No queue in many other languages, in C, C++, in Algol, Pascal, Fortran, nobody has that. But it is also important to have files. So files can be sequential or relative or index files. So the question is, what kind of support you have for sequential file? First, is the file consisting of records or it is a string of bytes? If you have records that have like lines of code, that is good because you can have file that consists of driver license of people. Okay. If you don't have that, well, you have to make that yourself in some way, and then it is less comfortable. Relative file. Sequential files have read, write, and append. And relative file have direct access according to record number. So access record number 5, access record number 10. Index file has direct access according to key. So you have that inside your record, you have something that you define as a key. And you can say key is the address, for example, of people, and then you go to that specific key. It is selecting from the set of records one that you need. Is this available in C, C++, or Java? No, it is not. You don't have it. Forget it. And is it available in COBOL? Yes, it is. And it is fantastically working. So you say, give me all red Volkswagen cars, and they jump immediately from your file, and you can process them. If you are searching for Volkswagen that is red, that has some 3 digits at the end that somebody made an accident and then escaped from there. So I want to say simply that these things are good if you have them. If you don't have them, it is bad. Dynamic data structures can have variable structures, list, tree, and pointer. So list is linearly linked list of nodes, and each node is a record of any complexity. You can have tree. Do you have a language that has data type tree? Of course not. But do you need that? Of course, yes. So obviously you need that. And what I want to claim, put this list in your mental computer and think at this level, not at the level what exists in my little language that is called C. Okay. What exists inside, you know what exists inside, but you have to think wider, outside of that frame, outside of that box. Pointer mechanism is one of mechanisms that is helping to make variable structure with variable size and variable everything else. So you can say this is classification of basic data types that exist in various programming languages. So static, dynamic, variable size, variable structure, scalar structure, and among scalar, ordinal, and real and complex. Do you have complex numbers in C, C++? Of course you don't. Okay. So whenever you do any engineering computation that has to do something with something that moves, you need complex numbers because Laplace transform is going to transform your time function into a complex polynomial. So you badly need complex numbers. Do you have them in C, C++, Java? You don't have them. Do you have them in Ruby? Yes, of course. That's the first thing. Do you have them in Fortran? Yes, you have from day one, because it was developed in order to serve engineers and things that are moving around. So again, I want to promote respect for each and every language that is supporting something good that you need. But we don't have language that supports all this. But we do have our mental computer that should support all this. So when you develop your software, think in this form. Now, this classification can be used for comparison of languages. So you can say, okay, I have here Fortran and COBOL. So I'm going to put in this table plus if you support logical data type, and minus if you don't support that logical data type. Or anything else. So if you come here to index file, we'll say, Pascal doesn't support, BASIC doesn't support, Fortran 77 doesn't support, COBOL does support, Ruby does not support, Java does not support, and put pluses and minuses. And then when you have to compare languages, look at this list and who has plenty of pluses or who has pluses where you need them. For example, if you want to develop some mathematical software, you better have complex numbers. So select language that supports complex numbers. If you go to Ruby, that support is fantastic. With complex numbers, you can do all solving complex equations in no time and completely as in mathematics. Okay, so you have that beautiful luxury of complex numbers. If you don't have that, then you have miserable life that you have to say, there is a real and imaginary part. I have to have these two things. Now I have to develop a function that is adding two numbers and multiplying two numbers and dividing two numbers and putting them in exponential form. And all this is miserable, okay? So you better have that this is done for you. Not to mention that there are a gazillion of complex functions. Compute square root of complex number. Come on. If you don't have that written, you have to know plenty of math to do that. You will see that. So I'm simply claiming that it is good to have languages that support this and that you can compare them in this way. The same situation is classification of control structures. If you have control structures, you can say what kind of selections, loops, and jumps we have. So what are control structures that have to be supported by a programming language? First of all, you have sequence, explicit sequence. Sequence means grouping several statements in a single block. And then you have selections to select one among many objects, various ifs and switches, etc. Then you have loops, so something that repeats over and over specific calculation. And then you have jumps. You execute your program line by line, and then you want to jump at the beginning to make a loop. So you have to have some kind of branch of jump statement that is going to jump backward or jump forward in your program. So you have to have jumps. Then you can ask, okay, how to make a sequence? Well, many languages have sequence between begin and end. They say, here you begin, here you end, and what is inside is a sequence. So that is a good way to make a sequence. The other say you have pair of curly braces. So if you have pair of curly braces, whatever is inside is one single compound statement or block, and it has to behave as a compound statement. So that is a good thing. Now, selections. Selections can be if then else. So this is the branching in two directions. If then is a skip, when you skip something. Switch case is generalization of if statement when you have branching to many directions. If else is generalized if when you have plenty of if statements, one inside the other, and if then if else is something that is inside the then part. So this is all what can exist. So some languages support that, some languages don't support. Of course, if then is supported by all languages, and if then if else is supported by no language, and if else is supported by Ruby, for example, and some other languages. Then loops, how to classify loops? We have loops with conditional exit. We have infinite loop. We have loops with counter, so that you count 1, 2, 3, 4, or 0, 1, 2, and loops with counter and condition. So these are loops that can be classified as loops with conditional exit. While do is loop with the exit at the top. Do while is loop with the exit at the bottom. Loop exit and loop, loop with the exit in the middle. Infinite loop, loop and loop, you have infinite loop that repeats forever. Then you have loops with counter. First, loop with hidden counter. Perform this block 50 times. Who can do that for you? Can you do that in C++? Of course you cannot. You have to say first integer I, and then after that, for I equals 0, I less than 50, I plus plus, blah, 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 blah. Okay, it is much better to say perform this 50 times. Who has performed? COBOL has. There is also something like that in Ruby. So it is very important to have loop with hidden counter, so that you don't need a counter in many situations. Repeat this many times, but I'm not going to have to manually increment the counter. So it is very good if you have that. For two-step arithmetic loop, so for real variable x probability that is 0.1 to 1 with step 0.1 perform something. So for two-step. You again have this in some languages. Fortran has this, and as elementary do loop, it works this way. For two, going with successors or predecessors, Pascal has that. For initialization, condition update, this is for loop in Java or in C or in C++. Then for each in set, do loop that is going through elements of set. Perfect thing. You have to have a set, and then you say for all employees in a computer science department, do this or do that. Okay, so of course SQL has this as a select statement. That's the basic statement in SQL. But this for each in set do is very important loop, and good to have that. Loops with counter and condition. So you go for two step where condition is satisfied. All these loops with counter and condition are generalization of loops that are without that, but they have an if statement that is hidden inside. So you can say, for example, for each employee in this department where salary is greater than something, perform some computation. So for each employee in this particular department where age is higher than 35, compute something, okay, or where age is less than something. So this exists in SQL, but it should exist also in most programming languages. If it does not exist, then you have to make it, and we make that, of course. But it is better to think in terms of all these things and not in terms of a single frame called language. Okay, you are inside the language when you write software, and of course, but you have to think without restriction. So I try to convince you to think in terms of this general pseudo language that has all these goodies that exist in programming. Jumps can be break, exit from loop, or stop, jump to operating system, or return from subprogram, or go to, which is jump to arbitrary destination. So all these things should be available as much as you want. And here is, for example, classification of languages based on who supports what. For example, you can say for each set element in SEPDO, nobody is supporting that. But for example, 4.2, 4 down 2 is supported here in this language and not supported in other languages. So you have that languages don't support too much of this, but support some of them more, some of them less. Okay. So let us quickly see some of these structures. First of all, skip and branch. So how is this supported? In pseudo language, you say if C, then B, and if. So you have condition. If condition is true, you perform this block. Otherwise, you skip this block. So we say here is if, here is and if. If C is satisfied, then perform B. Otherwise, and. No semicolons, no anything. We have that if, then, and end if are word delimiters. Okay. And the question is how it is made in other languages. For example, in Ruby, you have various luxuries, and you can say, if C, then B, and, which is same as this here. But you can say, if C, and then in next line, put B, and put here, and. It works the same way. So you can write it with then, you can write it without then. Or you can use this condition as modifier. You can say, perform B, if C is satisfied. So you have three different ways to make if then. How many ways you have in C or C++? Only one. And in Ruby, you can write in three ways. So whatever you write in Ruby, Ruby will understand and will perform that. So you can start writing programs before you learn the language, more or less. So it is very easy because you have all this relaxed syntax that gives you freedom to express yourself in variety of ways. If then else, if you have condition, we have branching in one of these two ways. So if condition, then B1, else B2, and if. This is in pseudo language. Ruby, if C, B1, else B2, and you can have also put then if you want and put everything in a single line. So it is this way in this language. If you say how is that done in C, well, in C you have to put here curly braces, here curly braces, and there is no end because you have curly braces that tell you where is the end of this B2, so you don't need to have end. Okay, we can survive with that also. Switch case is a command that has branching in many directions and has a selector variable. Selector variable must be ordinal data type. Ordinal data type. So it has to be 1, 2, 3 up to n. And then if it is not in n, then you have the default value. So in pseudo language, you have case S of 1, perform block 1, 2, block 2. So if this selector variable is 1, 2 up to n, then you are selecting blocks, block 1, block 2 through block n. Else, perform whatever is default. So if selector is not in this set from 1 through n, then you are performing this default block. And this is end of case. Of course, it is not necessary to put any break because this is selecting one of these objects. So why would you put break here like in C or C++ or similar languages? This is not a good taste, okay? Because you never go drop from one to the other, you always jump to the end of it. So you have that sometimes you have good taste for a case, sometimes you have bad taste for a case. But case is a structure that is generalization of if, and you go in this way. You have if else if else. If else if else is the generalization of if. So you say if condition 1 is satisfied, perform B1. If not, is maybe condition 2 satisfied, then perform B2. If not, then is condition 3, 4. And is the last condition satisfied, perform Bn. If nothing is satisfied, perform this default way. So default statement. So if C1, then B1, else if C2, then B2, etc., etc. And so this is in C or C++, you don't have else if. You have to say else, and then if as a new statement. It is similar. In Ruby, of course, you have this luxury. You say if C1, B1, else if C2, B2, else the end. This is the beginning of if, this is the end, and that is working perfectly and very easy. Or you can say if C1, then B1, else if C2, then B2, else if C3, then B3, etc. So this is the compact way of writing that, and also very readable and very comfortable. Okay, with then, but here you put that instead of then, you have a new line that is separated between condition and block. If then if else is construct when you say, may I execute this block 1? You have true. That means permit me to execute block 1. After that, you say, permit me to continue. You continue. Permit me to continue. And so after each permission, you go further and further. This can be written if C1, then B1. Then if C2, B2. Then if Cn, then Bn. And if you fail some of this, you go to default. So it is going through then generalization. This is infrequently used and not supported by programming languages. But there is no reason that you don't have this in your mental computer, that is executing these things. You have to have both if else, and if then if else. And then you make it in your language. If it is exist, you use it. If it does not exist, you make it, and everything is okay. So if you want to have classification of loops, this was theoretical question on exam. Classify the loops and show examples of that. So loops with conditional exit, loop with the exit at the top, while condition, perform body. Loop with the exit at the bottom, do body while condition. Loop with the exit in the middle, while one, infinite loop, perform B1 if exit, break, and then B2. This is C, C++, Java style. Loop without exit, infinite loop. Do body while one, for example. Loops with counter, loop with implicit counter, perform paragraph 50 times. You don't see the counter, you don't instantiate, you don't increment, you don't take care of that. Somebody does that for you. Perform this piece of code 50 times, n times. Loop through set elements. For each element in set, do body. Loops with explicit counter, arithmetic, successor, predecessor, loop with general update. So this is our for loop. For I is 0, I is less than n, and perform update, and you have that I is update of I. So this is the general update which you have in C, C++, Java, similar languages. Okay. So these are loops with counter. And then you have loop, counter, and condition. So for example, for each element in set where condition is satisfied, do body. So you take elements from set where condition is satisfied, do body. So for each employee in university where age is less than 30, do something like this. Okay. Loops with explicit counter, for example, basic for I equals A through to Z with step S, where condition is satisfied, perform body, and then the next I go back to this loop. Or a successor loop where condition, or predecessor loop where condition. And this is, I think, good place to make the break, and we'll continue next time from here. Any question? As always, pay attention that you can unmute your microphone and ask question at any time during the lecture. In addition, you have, of course, office hours that are going to be in 1 p.m. and feel free to come between 1 and 2 to office hours. Thank you. That's all for today.